If you feel like the weather has been going off the rails lately, you are not wrong. So floods, heat waves, wildfires, freak snowstorms, it's all connected. The Earth's climate system is breaking down, but how exactly, right? And what the science says about where we're heading. So today, we're going to talk about how there's 5 major ways that climate change is pushing the Earth systems to the brink. And trust me, this isn't just weather being weird here. So we're talking about fundamental shifts about how the planet functions. So let's start with the obvious one here. Temperatures are rising, and according to NASA, the last decade was hottest on the record, and 2023 shattered heat records globally. So the planet average temperature is already 1.2 degrees Celsius higher than pre-industrial times. So that might not sound a lot, but let's put it this way. So just 5 degrees Celsius cooler was enough to push us into an ice age. We've already seen the consequences. Record-breaking heat waves in Europe, wildfires in Canada, so bad that the smoke reached New York, and even parts of the ocean is hitting 38 degrees Celsius. Basically, ocean water is hotter than your jacuzzi. So the oceans are basically Earth's heat sponge, and they've absorbed over 90% of excess heat trapped by greenhouse gases. A hotter ocean means a mess of consequences. So first, there's coral bleaching. The Great Barrier Reef has suffered 5 mass bleaching events over the last 8 years. And second, stronger hurricanes. So warmer water fuels more intense storm. And third, this one we definitely know, sea level rise. So it's very simple. Water expands when it's warm, and ice melting from glaciers adds to the whole mix. And since the 1900s, sea levels has risen up to 20 centimeters, and they're accelerating. Ice acts like the Earth's sunscreen. White surfaces reflect the sunlight, keeping the planet cool. But the Arctic sea ice had been shrinking at 12% per decade ever since the 1980s. And some scientists predict that we could see an ice-free Arctic summer by the 2030s. Greenland alone is losing about 270 billion tons of ice per year. That's enough to flood an entire country. And if we lose significant portions of Antarctica, we're looking at several meters of sea level rise, which would drown cities like Jakarta, Miami, and some parts of London. And ever wonder why we're seeing bizarre weather extremes? Meet the jet stream. The jet stream isn't just any wind current. It's a powerful, high-altitude river of air that actually acts as like our planet's weather controller. So it normally flows smoothly from west to east, keeping weather patterns moving along. But as the Arctic warms, the temperature difference between the polar and the tropical air shrinks, and this weakens the jet stream, making it wobble and slow down, and sometimes stalling completely. And when that happens, weather patterns get stuck in a place. So instead of moving on, heat waves and storms actually linger for days or weeks. So it's fueled by temperature contrast. And because the Arctic is warming much faster than the rest of the world, that contrast is weakening. The result is a stuck weather systems. We've seen this in record-breaking heat domes over Europe, Texas, freezing over in 2021, and prolonged droughts turning fertile lands into dust bowls. And now, for the wild card, it's permafrost. So permafrost is permanently frozen ground, mostly in the Arctic, and it holds nearly twice the amount of carbon that's in the atmosphere today. But as it thaws, the carbon that is released is carbon dioxide and methane, a greenhouse gas 80 times more potent than carbon dioxide over a 20-year period. And there's this eerie phenomenon, methane bubbles escaping from Siberian lakes. So you know those videos you saw online where people are setting frozen bubbles on fire? That's methane, trapped in the ice, waiting to be released. And why does this matter? Well, because permafrost isn't just frozen dirt. It's like a giant freezer full of ancient organic material. And then when that thaw, bacteria will start breaking it down and release methane as a byproduct. If enough of this locked up carbon gets released, it could trigger a runaway feedback loop and accelerating warming beyond our control. What makes climate breakdown even more alarming is that all this doesn't happen in isolation. So one shift triggers another, creating this whole domino effect. For example, so when Arctic ice melts, it speeds up ocean warming. And that, in turn, fuels more stronger hurricanes, which leads to more destruction and displacement. So similarly, when permafrost thaws, it releases methane, which accelerates warming, causing even more ice to melt. So this is what we call a feedback loop. that what all scientists are warning us about. Because once this loop go into high gear, stopping them would be nearly impossible. And we often think climate change as a slow-moving problem, but these interconnected systems can cause rapid shifts. And if we cross critical thresholds, like major ice sheet loss or widespread permafrost thaws, we may actually reach the point of no return. So, where does this leave us, right? The climate system is unraveling, but we still have a chance to stabilize it. Every fraction of a degree matters. So avoiding 2 degrees Celsius of warming instead of 3 degrees Celsius could mean saving millions of lives in an entire ecosystems. So science tells us the risk, but it also tells us the solutions. Cutting emissions, restoring forests, scaling up on renewables. These aren't just buzzwords anymore, they're necessities. The Earth's climate system is breaking down, but it's not beyond repair. Yet the question that we all have to ask is, what are we willing to do about it?